Hey guys, welcome back to DeepShift Labs. In this video, I'm going to be explaining the basics of artificial intelligence and intelligent decision making. We'll also take a quick look at TensorFlow and Keras. So, what is an AI? An AI is the use of mathematical equations with parameters to create an artificial sense of intelligence in machines. We can use mathematical equations that have different parameters, and by changing these parameters we can accurately model practically any real-world application or formula that may not be easily derived. So, let me give you a theoretical explanation of AI. Trust me, it isn't rocket science. So, the structure of an AI is quite similar to one of a brain. It involves nodes, namely the input node and the output node, as well as several hidden layers. And these hidden layers are what actually model different real-world scenarios. Basically, the input goes in the form of numbers. So if it were text, we'd have to vectorize the text. If it were images, we'd have to normalize the images. And don't worry, all these terms are coming up soon. Then, some magical mathematical formula would be running inside this hidden layer. It would change and tweak and tune the data until we have exactly what we need. In the case of an image, it's going to take the image, tweak it, tune it until we know exactly what it is, a cat or a dog. And again, it works very similar to one of a human brain. So the formula, oh no, is that calculus? No, it is actually a very easy formula, and I'm going to break it down for you. So here is a sigma summation. It basically says over these many number of iterations, sum through this. Similar to a for loop in programming. And what we're doing is xi here, xi is the input. And the input is going to get multiplied by a weight. Now this weight is unique to the input. So if this was input 1, then this would be weight 1. For input 2, there would be weight 2, however. And these change based on each input. So they get multiplied and then summed up together for all the inputs that exist. And then we add one giant bias to it. And essentially what we can do is, when we're training, we can modify this weight, we can modify this bias. And by changing and tuning this for each node, we can model practically any real-world application. So again, if we look back at this chart over here, the formula would be running in this node, in this node, in this node, and in this node. And these inputs would come in, so this would be x1, the input from this would be x2, and this would be x3. It would assign each one of them a weight, so weight 1, weight 2, and weight 3. It would multiply them, sum them together, and then add the bias to it. And this output would be the input of the next node. So imagine if we had several hidden layers. So this would be like a chain going from one node to another node to another. And we would end up with a very powerful way of modeling complex applications that we could not normally derive mathematical formulas from. So as I said, the weights get multiplied, then the bias is added, and this runs for a set number of iterations. So, you might be wondering, is there only one type of AI, or are there several? Well, you'd be pleased to know that there's no one AI that can do everything. We have CNNs. No, not central news network, but convolutional neural networks. Although that last word does match, which makes it kind of funny. These convolutional neural networks work with images mainly. What they do is they have a special type of layer called a convolution. A convolution is quite complex, and we'll cover this in later parts of this series. But basically, these types of neural networks are used for object detection. Then you have RNNs, or recurring neural networks. These neural networks are used to look at patterns in the data for natural language processing. So if you had a set of text like, "Hi, how was your day?" then it would be able to see, so after hi comes how, and after day comes a question mark. And it will learn these types of patterns throughout a time series. So while convolutional neural networks are time independent, recurring neural networks are time dependent. And we have a last one that I decided to include. Now, if you have been following up with the AI news lately, you know that OpenAI recently released GPT-3. GPT-3 is a powerful AI that is also happens to be a transformer AI. A transformer AI gathers data from a variety of different sources. And in the case of GPT-3, they actually crawled the internet, Google, and got as much information from them as possible. And using this, what they can do is they can find patterns in the data. For example, one of the things GPT-3 can do is if you give it a description of a website, so I want a gray banner with a blue background, this text here, this text there, a few buttons, the Transformer AI automatically knew how to turn that into a website. So how this does it simply is it compresses the data and then runs a neural network similar to the one we described previously on it, except this time it's a type of autoencoder, and we're going to again discuss this in much more depth in later videos of this series. And then it's able to recreate the output we want from a completely different set of inputs. These are a very prevailing form of study nowadays. And no, it's not Bumblebee, although Bumblebee may be using some Transformer AIs, who knows. So, how do we make an AI? And no, we won't make Ultron, not yet, although there is a future part coming in this series. I'm kidding. So, the first thing we have to do is data wrangling, cowboy style. So, programming, there are a few different languages you can use to do data wrangling and programming. Here are some good ones: Python, C++, and R. Now, no, we're not picking the Python from a zoo. No, don't worry, it's going to be normal Python. C++ is primarily used for hardware applications such as robotics and stuff. Python is primarily used for the AI itself because it has TensorFlow and Keras support coming up later. And we have R, which is an emerging language, but a very powerful data science language. So, different types of data wrangling. You have image normalization, which scales down the image because if the images are different sizes, then we're going to have different sized inputs, meaning the entire AI will be confused on what's going on. If we scale them down also, it doesn't require as much processing power. We have to change them to a RGB color scheme, or a digital color scheme of some sort. And this is generally done to further make sure all images are the same. And we have to categorize these images into folders. And no, we're not discriminating against images. No, not yet. Text vectorization. So, text vectorization involves taking text, which is generally ASCII. So, it's very difficult for an AI to directly interpret text. We have to somehow convert it to numbers on which we can run those formulas we previously described. And text vectorization does just that. And we will explain text vectorization more in our recurring neural networks video. Some other ones are DropNA, which drops off all null values. This is generally done for CSV files. Popping is also done on CSV tables, and this tells the AI to look over here to focus on this. This is what we're going after. And removing outliers, this is obvious. We don't want to throw the AI off because of some random data that got thrown in. And yeah, we don't want to be the odd one out, you know. So, if you've done everything I said so far, I'm sure you're going to be getting horrible accuracy, but there's a reason for that. You see, that one equation alone can't make an AI. It's just not complex enough. It doesn't allow room for learning, and since the real world is so random, we can't just do that. And that's why we have loss functions and optimizers. Loss functions. And as Ultron put it, you can always learn from losses. So some popular loss functions that you're going to be most familiar with in your AI learning journey is going to be sparse categorical cross-entropy and binary cross-entropy. Now, if you know a thing or two about physics, you must know what entropy is, and this works in a similar fashion. We're not going to get too much into this today, but maybe some other time. You also have mean absolute error, which calculates the error using a very simple formula where it squares the error and then does an average of those over time. Gradient descent is another one, and basically it works in a similar fashion too. Imagine you had a ball somewhere here, and you let it go. and it would naturally roll to the lowest point on the map. That's basically what gradient descent does. Using a set of differential equations, it's able to figure out what the lowest point on the graph is. Some optimizers. Optimizers are essentially what say, okay, here's the AI, here's how bad it's doing, and we know how bad it's doing because the loss function told us that. And it's like, okay, so from here, what can I do to make the AI better? What weights, what biases could I change? What nodes could I change to make it more efficient, more better? How could it model the situation more accurately? Some popular ones that just came out recently is Atom. And then we have gradient descent with momentum. And that's similar to gradient descent we talked about, except we implement a slight physics concept of momentum into it to make sure we don't get stuck at a false bottom. A false bottom is essentially where if you have several bumps in the map, then imagine a ball could get stuck in a crevice and not be able to go all the way down. And that's what momentum fixes. And here is the crazy complex formula we don't have the time for. So what is TensorFlow and Keras? I'm sure you have heard of it. You might also know that TensorFlow is a product of Google, and Keras is now also owned by Google. Well, TensorFlow is a powerful deep learning library for Python. It has a lot of deep learning features as well as machine learning. And essentially the difference between them is quite simple. Machine learning is usually classical algorithms such as like linear regression to figure out patterns in the model. And deep learning is the neural networks we previously talked about. And more information on them is coming up later. It has lots of features, it's open source, owned by Google, good documentation. But TensorFlow on its own is extremely difficult and has a steep learning curve. But that's where Keras makes it easy. Keras is an API that's put on top of TensorFlow to allow you to use only a few lines of code to have a powerful AI in your fingertips. And just to show you how easy it is, here's a sample AI that we made. This AI is able to differentiate between different types of flowers. And I'll be honest with you, I can't differentiate between flowers, so I would say this is pretty impressive. And let me break this down for you. We import all of our libraries. In this case, we're importing TensorFlow and Keras. We load our data directory, our batch size, all these different parameters as we call them. These are called hyperparameters, by the way. And then what we do is we load the data using this image dataset directory command. And there are a bunch of settings here. We're again going to explain this in much further detail later. And then we have the actual model. As you can see here, we have a convolution, and that should tell you that it is a convolutional neural network. We have a flattened layer. We're going to explain this in the convolutional network video. We have a dense layer, which is the standard layer we talked about with the summing the weights and biases, if you remember. And we compile the model. And look, here we're using the Atom optimizer, and we're using the loss sparse categorical cross entropy. And so then we load up our checkpoints, and this is basically going to store the AI model somewhere. We load our logging directories, and that's going to log the progress of the AI, and we train the model. Look at how easy this is to make an AI. And if you don't understand this right now, don't worry. Future videos will cover this in great detail. If you are still confused or want to learn more, please check out 3Blue1Brown's video on neural networks from ground up. It's a great introductory series, especially if you want to learn the maths behind it. If you want to know what differential equations and what exact math is running behind these optimizers, please check out his video. It's incredible. So thank you for your attention. If you have any questions, please leave them in the comments. And please consider subscribing to our channel. It really helps us out. And you can now also contribute to our Open Collective page to make sure we can keep teaching other people about the powers of AI. And until next time, don't make an Ultron.